in which in this video we'll study IGCSE Computer Science Chapter 2 called Data Transmission. So in our previous video, we learned how the different types of data, such as sound, images, text, numbers, they can be represented in binary. However, computers wouldn't be that useful today if they can't send all this data from one computer to another. Therefore, computer scientists have come up with ways for people to transmit data from one computer to another. So we will study all these things in this video. And let us first understand how data is transmitted. And for every message, this message can be your videos, can be your text. They will be broken down into multiple data packets when they are being sent. And if we were to examine all these data packets, the packet size is roughly 64 KB. So if your data is around 1000 KB, you will roughly have 13 packets when you are transmitting your data. And all these packets will need to be reassembled to form the original message when it arrives the destination. And let's first examine some of the structures of the packet. And a packet is basically split up into three parts. First part is the header, the payload, and also the trailer. And let us examine the header of the packet. It contains mainly four items. The first one is the sender IP address and also the receiver IP address. Storing this information allows the packets to know, alright, where should I go to? Alright, and the header of the packet also stores the sequence number of the packet. As mentioned, a message is usually broken down into multiple packets when it's being sent. Therefore, the order of how the packets is important. This is especially useful when the packets reaches the destination so that we know which is the first packet and we can reorder them together to reassemble them. And last but not least, the packet also stores the size of the packet. This is to ensure that all data, the receiving station can check that all of the packets have arrived and that there's no one there to steal the data. So that's the header packet structure. So one way that I use to remember the items inside header is this mnemonic called SSSR. S stands for sender IP address, receiver IP address, sequence number, and also size. Alright, so let's move on. The second part of the packet is called the payload. It basically stores the actual data in the package, right? Very straightforward. And followed by the trailer of the packet, in which it is just some ways to identify the end of the packets to tell the receiving station that this is the end of the packet. And they also allowed each packet to be separated from each other as they travel from sending to receiving station. So to illustrate, imagine these are all the packets. So the trailer part of the packets, shown by the red highlight, basically signifies the end of a message. Alright. Another function of the trailer is to allow some error checkings to make sure that the data arrived is the correct data that's being sent. And one method that is used to do that is called the cyclic redundancy check, in which, let's say this is our payload. It stores a bunch of 0 and 1, alright? And how do we check whether the payload is arriving correctly? So in cyclic redundancy check, what this method do is that it will first count the number of 1 bits in the payload. So if you were to count the number of 1 bits, you will find that it contains 15 1 bits. And this number will then be converted into hexadecimal, which is the value f, and this value will be stored in the trailer part of the packet. And how do we know if use this method to identify errors? Is that, let me give you an example. Imagine that this is the original data, and when the original data is received, one of the bits have been swapped. And by using cyclic redundancy check, we can actually identify the error that happens here. So we'll use the same method to calculate the number of 1 bits in the message and then convert it into hexadecimal. And this hexadecimal will then be compared with what is stored in the trailer part. And if the difference is different, then the receiving station will know that an error has occurred during data transmission. Alright, so that's cyclic redundancy check. It basically works by counting the number of 1 bits in a packet. So that's the structure of a packet. So next up, we are going to discuss a mechanism where message is transferred called the packet switching, in which it's something that we already mentioned just now, just that we didn't give it a bit terminology back yet. So let's read this. Packet switching is a method of data transmission. It's the types of data transmission in which the message is broken up into a number of packets, and each packet can be sent independently from start point to finish, which means all the packets doesn't have to work in group. They can follow their own track sent by different routers. And at the destination, the packets will need to be reassembled in the correct order. If we remember correctly, the way they do this is to use the sequence number that is stored under the header of the packet. Alright? And at each state in the transmission, there are nodes that contains a router, and the router will determine which route the packets needs to take. So let's explain. This is what happened in packet switching. A message is broken down into multiple packets, and when it arrives, it needs to be reassembled. Alright? So that's packet switching. To explain it better, let's look at the other. There's a little bit laggy here. So let's look at this image. So imagine that you have a message here in computer A. So as we said, how packet switching works is that it will break down this message into multiple packets, P1, P2, P3. Okay, so which is what is in our here. If we have a router here, the router will determine which route each packet should be sent to. So for instance, for packet 1, and when it arrives router A, it will be sent independently from one point to the destination. Okay, so that's the route for package 1. And as for package 2, it can follow another path here to the same destination. And the path is determined by the router. So routing selection depends on the number of packets waiting to be processed at each node, which means the router decides which path the packet should take depending on how busy a particular lane is. And the shortest possible path available is always selected. That ensures that the message can arrive quickly. And lastly, packet can arrive in different orders compared to the way they were sent. Remember, eventually they will be reordered using the sequence number in the header, so it doesn't matter which packet arrives first. So that's packet switching, the essence of it. And in the exam, they might ask you what are the benefits and what are the drawbacks of packet switching. And there are two benefits, is that there's no need to tie up a single communication line. Can you imagine that if we look back? Can you imagine that if we only have one route here, and we have a lot of packets to send, and just like how the traffic on the road is, the data transmission will be slowed down due to a delay. Therefore, with packet switching, since we are breaking packets into multiple packets, we don't have to type up a single communication line. Each packet can be sent using a different route. And a high data transmission rate is possible because data can be transmitted quickly. And as for the drawbacks, and they said data can be lost and need to be resent, which means when they are being transmitted here, somewhere around the road, someone might hack this data or steal this data, and as a result, the data might lost and a resend is required. And a delay at the destination while the packets are being reordered is the second disadvantage, in which it takes time for us to reassemble all the packets into the original message. Alright, so let's move on to the different ways data can be transmitted. So there are several methods of transmitting data depending on the types of hardwares and connections being used. And we have two types of data transmission and three different modes of data transmission. The types are serial or parallel, and transmission mode can be categorized into simplex, half duplex, and also full duplex. And every data transmission can either be serial or parallel, and simplex or half duplex or full duplex. So for instance, a data transmission can be serial and simplex, and the other could be parallel and half duplex. So which means every type of data transmission is either serial or parallel, or simplex, half duplex, or full duplex. One way I always explain to my students is that just like how McDonald's do mix and match, you pick one from the left hand side and you pick one from the right hand side. Okay, so let's look into the types of data transmission first. What does serial and parallel mean here? So serial to data transmission occurs when data is sent one bit at a time over a single wire channel. The two keywords here is one bit at a time and over just one single channel. And bits are sent one after the other. Just look at this diagram here. If the sender were to send message to the receiver, it will send the bit one by one instead of multiple bits at the same time. So this is serial data transmission. And as for an example would be a computer connected directly to the printer via a USB connection. Alright, so that's USB. And as for parallel data transmission, it occurs when several bits of data are sent down several channels wires all at the same time, which means in just one particular second, multiple bits can be transmitted. So this is how it works. So this could happen in 1 millisecond, and 3 bits are sent at the same time. So this is called parallel data transmission, such as the internal circuits in your computer. That's just one example. And here are we'll also study the advantages and disadvantages in serial and parallel data transmission. Understanding this is important because in the exam they might give you a scenario and you will have to explain whether we should use serial or parallel data transmission. So knowing the disadvantage and disadvantage allow us to make the right choice. So the advantage of serial data transmission is that it is very reliable because data is sent one bit at a time. Therefore, there will be fewer errors. And the disadvantage of it would be that it is very slow because one channel is used. So parallel data transmission, it allows faster data transmission as multiple channels are used faster. And parallel data transmission works well over short distances, all right? And as compared to serial, it works well over long distances. Parallel, it works well for short distances. And the disadvantage is that one of that is that it's more expensive. And the second of it, which is more common, is that synchronization errors can happen. Remember that multiple bits being sent at the same time. So the order which they arrive, they therefore become important because they need to be reordered correctly. All right. So that's serial and parallel data transmission. And let's look into the 3 different transmission modes and what do they mean. And per transmission mode, we can categorize them into simplex, half duplex, and full duplex. And simplex mode occurs, the first mode, when data can be sent in one direction only. All right. So let's say laptop to printer. This is simplex data transmission mode, in which you can send data from your laptop to your printer, but the printer cannot send something back to your computer. Okay. So the second one is called mode is half duplex, in which data is sent in both directions, but not at the same time, such as a walkie-talkie. So for instance, data can be sent here, from here to here, but they cannot happen at the same time. Right? So that's how it works. So the third transmission mode is called the full duplex transmission mode, in which data can be sent in both directions at the same time, such as your broadband internet connection, right? In which you can send data to your broadband and the router will send it to the outside world and vice versa. So again, let's look at the advantages. For simplex is that it can use the full bandwidth for the channel because data is being sent only in one direction. It can occupy the whole channel. And the disadvantages of it is two-way communication is not possible. And so half duplex, they enable two-way transmission. However, there will be a delay in communication because data cannot be sent at the same time. All right. And as for full duplex, it is the fastest duplex transmission method due to each communication using its own simplex channel. There's no delay. Data can be transmitted two-way. All right. And the disadvantage, which some networks are not able to utilize the technologies, is some advanced technology here. So one thing to learn about it is that just as I said, data transmission can either be serial or parallel plus simplex, half duplex, full duplex. So let's imagine that this purple color text is the question. They said data is sent one bit at a time in one direction only. One bit at a time, which means it is a serial data transmission in one direction, which means it is a simplex data transmission. Okay, as simple as that. What if they said data is being sent 16 bits at the same time? At a particular time, 16 bits are sent, and in both directions simultaneously. Simultaneous means that data is being sent at the same time. So it will be parallel data transmission because multiple bits are sent at the same time, and full duplex. It sends in two directions at the same time. All right, so that's the types and modes of data transmission. Make sure you understand what are the advantages and disadvantages of it so that you can understand which data transmission mode use depending on the scenario given. All right, so the next subtopic that we are going to go into is called a universal serial bus, USB. All right, universal serial bus is a form of serial data transmission. As implied by the name, we can actually already know because it's called serial bus. Therefore, it transmits data in a serial fashion, one bit at a time. And USB is a type of communication port. You can find it on your computer in order to do away with the older forms of ports. And it's now the most common types of input and output port. This is, you can find that USB is everywhere. It can be connected to your mouse, it can be connected to your keyboard, your webcam. They are just universally used. And it allows half duplex and full duplex data transmission in two directions. For instance, your USB pen drive, you can receive data, you can transmit data from the pen drive to the computer, and also in the other way around. Okay, so that's USB. And USB cable, if you were to dissect it, you will find 4 cables. The red and black cable here, are for power. You will notice that sometimes your USB cable will be able to charge a phone. And for white and green cable, it is for data transmission. Okay, data transmission. Okay, so there's another type of USB cable coming up already there, which is called USB-C. And as compared to the normal USB, it has 24-pin symmetrical connector, which means it will fit into the USB port either way around. So either the front or the end, it can be connected. And it is much smaller and thinner, and it offers much more power, 100 watts, which means full-size devices can be charged more quickly and it can carry more data, as according to the slide here. So that's all about USB. And the advantages of USB is that it's very ubiquitous, it is everywhere, therefore manufacturers would like them. And they are able to supply both power and data. You can either transmit data or you can charge your gadget using the USB connector. And it's backward compatible because there are multiple versions of USB out there, 2, 3, 4. You can use the same pen drive on the less modern USB system. And as for the disadvantages, data transmission speed is still relatively slow. It's not that fast yet. And transmission quality will deteriorate when the cable becomes too long. Alright, so that's some knowledge about what USB is. Alright, next up. The next topic is called methods of data error detection, in which this topic is important because from our previous lecture just now we learned that data can be transmitted from one com to another computer. But how do we ensure that all this data arrive correctly? One method that we have learned is called the cyclic redundancy check, in which it checks the number of 1 bits. But there are more methods that can be used here, which can be more effective. So just some introduction here. Here we have a text here. And if you are able to read it, congratulations. However, this is clearly a corrupted message in which all the words are being corrupted when it is being sent. Imagine that this is a message sent to, you send it to your friends, and they wouldn't be able to understand what you are writing here. But the computer wouldn't know this. They will still display this message. They wouldn't know data transmission has occurred. Therefore, we need to check error. We need to check error during data transmission. And because errors can be happen due to the following reasons, such as interference, all types of cable, when data is being transmitted in the cable, it can suffer from electrical interference, which can cause data to be corrupted, such as 1 become 0, 0 become 1. And it's also be problem during packet switching, alright, and also due to skewing of data. This occurs during parallel data transmission and can cause data corruption if the data is arriving out of sync. So there are 5 error detection methods that we will learn in this video. First one is called parity check. Let's move into it. So imagine that this is the data here. We have a data of 1, 2, 3, 7 bits, and this is the upper one is the original data, and this is the one that is received. How can we know that this entire block of data have been corrupted? How do we know that they have been corrupted? And one way that we can do this is through the parity check. So parity checking is one method used to check whether the data has been changed or corrupted following data transmission. This method, very similar to cyclic redundancy check, is based on the number of 1 bits in a byte of data. Okay, the parity check can either be called even or odd. Therefore, we have 2 different types of method here. So let me go back. So your parity check can either be even parity check or odd parity checks. There are 2 different methods. And the way that we can do this is by using the leading bit as our parity bit. So let me explain how this works. So let's say we have a byte of data here, and to set up the parity bit, we can do this. The parity bit is set according to whether the parity being used is even or odd. For example, consider the following byte, and just bear with me. Imagine that now we are using even parity check. To determine what to put as the parity bit here, we just have to first determine, is it that I need an even number of 1s, or do I need an odd number of 1s? So since I'm using even parity, I need an even number of 1s. Even number of 1. So to have an even number of 1 bits in this byte, the leading bit has to be 0, so that we will have 1, 2, 3, 4, 1 bits in our bytes. So that's how we set up a parity bit. So in another example, we can see that if I want to have an odd parity check, my parity bit will have to be 1, so that eventually I can have 1, 2, 3, 4, 5 bits, 5 1 bits, which is the odd parity bit. All right. So next up. Okay. So there's some laggy scenario here. So to summarize, the steps to set up a parity bit is to first count the number of 1s in our bytes. So for instance, here I have 4 1 bits here, and ask a question: are you using an even parity or odd parity? And based on the types of parity check, we decide what to put as our parity bit. Okay. So let's look at how using the parity bit can help us to determine whether an error has occurred. So let's say that currently we are using an even parity check, and as you can see, the leading bit is 0. Our parity bit is 0 to make sure that the number of 1s here is equal to 1, is equal to even. And imagine that a bit is corrupted here. A bit is corrupted. And the receiving computer received this byte of data, alright, he knows that even parity is used, and therefore he will calculate whether the bytes contains an even number of ones, and it will count 1, 2, 3, and it only got 3 1 bits here, and immediately the receiving computer will know that, hey, something is not right, the byte should contain an even number of ones. And this is how errors can be detected by the receiving computer. They will calculate the number of 1 bits, and they will see is even or odd parity used. And based on the answer, they will determine whether the bytes have been corrupted or not. Alright, so here are some questions. Let's determine whether the error has occurred. And in this message, they said that even parity is used. And therefore, we should expect this byte to have an even number of 1. Even number of 1. And we can count 1, 2, 3, 4, 5, 6. And because they have an even number of 1, this means that, alright, error does not occur. Does not occur. Okay? So in the second question, they said odd parity is used instead. And again, we expect an odd number of 1. Odd number of 1. But when we calculate the number of 1 bits in this byte, we found that there are 8 1 bits here, which is in even. Therefore, since it doesn't match, this means that error has occurred. Error has occurred. And this is how we can determine whether a message has been corrupted or not. Alright, however, there's a problem with parity check in which it doesn't work in every scenario here. So imagine that instead of 1 bits being swapped, we have 2 bits being swapped. Alright, and there's an even parity is used. Again, the receiving computer will calculate the number of 1 bits, and it find that, hey, they have 6 1 bits here. Hey, error doesn't occur. Error does not occur from what the receiving computer knows. But from what we see here, 2 bits have been corrupted. And therefore, the conclusion that we have here is that when 2 bits or even an even number of bits are corrupted, parity checks will fail. Okay, I repeat, when 2 bits or an even number of bits are corrupted, parity bit will not work. They will not be able to determine the number of bits that are being swapped. Alright, so let's move on to the second method where data detection can be carried out, which is called the checksum method, which is when a block, there are multiple steps here, I'll just go through them one by one. And imagine that this is our data here from 1 to 8. And very similar to parity check, the checksum method also reserves one spot here to place it as the checksum value. Checksum value. So let's read point number 1. When a block of data is about to be transmitted, the checksum is calculated from the block of data. The calculation is done using an agreed algorithm, which means we determine the value of the checksum based on the value from 1, 2, 3, 4, 5, 6, 7. Alright? The algorithms here, this is just an example. It can be different algorithms, but this is what I have chosen, is that I will sum all the numbers here. Number 25, 37, 15, 45, 32, 13, and 6. And divide the sum by 7. So let's try to do this. If I were to sum all this number up, I will have the value of 173. Okay, 173. And when I divide this number by 7, I will have 24 with remainder of 5. Remainder of 5. And according to this algorithm, we should take the remainder to be our checksum value. So our checksum value here is equal to 5. Alright? And then the checksum value is then transmitted with the block of data. So it means this value 5 will be transmitted alongside with all the other data. And step number 3. And at the receiving end, the checksum is recalculated by the computer using the block of data, which means the receiving computer will use the data here to calculate what should be the checksum value. Okay, this recalculated checksum is then compared with the checksum value sent. And this is how errors is detected. Because if two checksums are the same, then no data transmission errors has occurred. However, if an error has occurred, a request will be made to resend the data. So imagine that number 4 is the data that has been changed and that has been corrupted. And if we were to use the same algorithms, let's calculate 25 plus 37 plus everything, we will have 153, which is the sum. And our algorithm is to divide this sum by 7, and we'll have 21 with a remainder of 6. And therefore, since we use this as our checksum value, and when they compare it with the checksum value attached, immediately the receiving computer will realize that an error has occurred. So that's the essence of checksum. One thing to note is just that the algorithm used is completely customizable, which means the computer can decide which algorithm it wants to use. Alright, so let's move on to the third data transmission method, which is called the echo check. So here are some of the description. Upon receiving a message, the receiver will immediately send a copy back to the sender. A comparison will be sent out. If there's no difference between the two sets of data during the echo check, this means that no error has occurred. Otherwise, an error has occurred and the data will be retransmitted. To better explain this, I have a picture here, alright, in which let's look at the first step. Upon receiving a message, the receiver will immediately send a copy back to the sender. So imagine that this is the data that the sender sent to the receiver, 1010. And what this method will do is that the receiver will send the exact same data back to the sender, 1010. So that the sender can compare whether the data that is sent and the one that it received are the same. Alright? If there's no difference, then no errors has occurred. However, if there is a difference, let's say this data is being corrupted into 1111, and if the receiver were to send this back to the sender will know, alright, an error has occurred. It will then retransmit the data. One catch about this method is that what is stated here is that it isn't known whether the error occurred when sending the data in the first place or when the error occurred when sending the data back to checking. Because if you think about it, data can be corrupted here, alright, when it is being sent, but it can also be corrupted here, right? Therefore, if the data is corrupted in point B here, then the sender wouldn't know if an error has truly occurred. So that's the essence of echo check. Alright, so next one is called automatic repeat request. So again, let's look at the whiteboard for more clarity. So ARQ, automatic repeat request, they relies on two things. First one is the positive acknowledgement, positive and negative acknowledgement here, and also the second one is the timeout method. So imagine that the data error detection method mode here used here is the parity, which is here they have the odd parity using here, right? Therefore the parity B is 1, and the receiving device receive an error detection code. Let's look at line number 1 as part of the data transmission. This is used to detect whether data contain any transmission method. All right, so which means the transmission can be any methods, and if there's no method, imagine that when the receiver receive it, alright, there's no error because they are using odd parity, and this receiver will send a positive acknowledgement to the sender, say to acknowledge that data has been sent correctly. And however, if the data received is corrupted, let's say 001 instead, then the receiver will send a negative acknowledgement instead to acknowledge that the data received is not correct, and request the sender to send another message to resend the message. And last but not least, they also set up something called a timeout. by waiting a predetermined amount of time, which means that if the sender will set a timeout such as 20 seconds, and this means that if within 20 seconds I still do not receive any acknowledgement from the receiver, I will just resend the message. Okay, so that's the essence of timeout, and that's the essence of ARQ. So the last method, data transmission method, is called the check digit. It is used more commonly in barcode, and this error detection methods, what they say here is that it helps to spot errors during the data transmission across two different devices. And data discrepancy can occur due to the following reason. It can be due to human errors, such as an incorrect digit entered, or transition error, in which 5037 become 5307, the order has changed, and omitted or extra digit, 537 instead of this and that, and phonetic error, instead of 1330 is right, written instead. And how this works, one method of check digit is called the ISBN 13 method. You can check out the books that you have now. They're probably using the same method. And the checksum value, the check digit value is this, which is the 13 value, which is the most relevant one in our ISBN 13 method. And this 13 digit is generated using other 12 digits in a number. Different methods are used for different systems when calculating the 13 digit. And these 13 digits, they will help to determine whether an error has occurred. Whether error has occurred. Alright? So let's look into a real life example. So this is the algorithm used by ISBN method. Let's go right straight into our example here. So imagine that these are all the digits of a barcode, and this is our check digit. Okay? And according to the algorithm, the first step is to add all the odd numbered digits together, which means we add the first digit, third, and fifth, 7th, 9th, 11th digits together. So if we were to do this, we'll have the value of 29. And step number 2 is to add the even number digit together, which is the 2nd, 4th, 6th, 8th, 10th, and 12th digits. And the third step is to add the value here together and then divide by 10. So when we divide by 10, we get a quotient of 10 and a remainder of 1. And then based on the remainder, if the remainder is 0, then 0 is our check digit. And if the remainder is not 0, we will take 10 minus the remainder instead. Alright? So based on this, our check digit is equal to 9 because remainder is equal to 1. Therefore, we use 10 minus 1 equal to 9. So this is how we obtain the check digit of a barcode. Alright? So that's the essence of check digit. And these are the 5 methods that we have learned on how to check whether an error has occurred during data transmission. The parity check, which relies on counting the number of 1 bits. Checksum, which is more secured, and it relies on the first 7-digit value to calculate the checksum based on a agreed algorithm. Echo check, and ARQ, automatic repeat request. Last but not least, and this is the checksum method, check digit method. So let's move on to symmetric and asymmetric encryption. So the reason of why encryption is important is because when one party is going to send a message to another party, there is a risk that this message could be intercepted by some hackers. Okay? Therefore, we need to encrypt the data. In other words, we need to make this data, so for instance ABC, we need to encrypt it in a way that no one know what we are saying, right? Because however, encryption cannot stop a hacker from intercepting your message. However, it would just make no sense to them. Even if the hacker know that you are sending the message BD, it wouldn't know what it means. It wouldn't know what it means. So that's the function of encryption. So let us learn some terminology in the encryption subtopic. So before a message, a text go through an encryption algorithm, we call them the plain text. The plain text. Alright. After the plain text has gone through an encryption algorithm, we call them ciphertext. And the ciphertext here, when it goes through the decryption algorithm, it can be returned to plain text again. Let's look into an example of how this algorithm works. So the first types of encryption that we are going to learn is called the symmetric encryption. It uses an encryption key, and this key is used to encrypt and decrypt a message. And one method is called the Caesar cipher. So let's look at this message called, imagine that you have this message called I have COVID, and the key is 4578. How can we construct the encrypted message based on this key? So let's write down 4578 repeatedly, all right, to at the bottom of the text, and we can just use the key here to determine what is the encrypted character. So let's say I, the first character is I with a key of 4. And how we're going to do this is that we just need to move I forwards 4 times in the alphabetical order. So the character after I is J, right? If you look at the right bottom corner here, after J is K, 3, and 4, LM. So this is the 4th one. So we have the character M, the encrypted character. And the next one, H. After the word H, 1, I, J, K, L, 2, 3, 4, 5. It is also the character M. Okay? And by using this method, if we were to do it continuously, you will have the value of MMHDI, HVDMI, which is the encrypted text. And this is called the ciphertext. Another key term of it is called the ciphertext. All right? The I have COVID is the plain text instead. Plain text. As you can see here, if a hacker were to intercept this message, he wouldn't be able to know what you are sending to your friend because this message is completely encrypted. All right? So that's symmetric encryption. And to decrypt it, it's very simple. Imagine this is our ciphertext. If we were to decrypt it back to our plain text, we just have to move, since our key here is 4, we just have to move 4 steps backwards into the alphabetical order. 2, 3, 4. So we'll get the value of I. Alright, if we were to do this method continuously, you will be able to receive the same message. Alright, so why symmetric? The reason this algorithm is called symmetric encryption is because to convert the plain text to the ciphertext, we can just increase our steps in the alphabetical order, and to decrypt it back to plain text, we can use back the same value to move back to our plain text. Alright, so that's the symmetrical part of the algorithm. So some drawbacks of the symmetric encryption is that it's really difficult to keep the encryption key a secret. So if the hacker happens to have the encryption keys, then he or she would be able to decrypt the message, alright? And what is stated here is that it's really hard to keep the encryption keys secret because both the sender and the recipient has the key, alright? Therefore, computer scientists has developed another method called the asymmetric encryption. What it used to overcome the security problems associated with symmetric encryption. Alright, it makes use of 2 keys called the public key and the private key. So that's the first difference between asymmetric and symmetric. Asymmetric uses 2 keys and symmetric only uses 1 key. And the first key is called the public key. It is made available to everyone. Everyone can have the key, and also the private key. So let's see how it works. When a message is cipher ready for transmission by a sender, the receiver will generate a pair of keys, a public key and a private key. The public key is used to share with any device, means everyone can have this, and the sender will use the receiver public key to encrypt the message. So the first point here is that public key is used to encrypt a message, and Point number 4, when the receiving device obtains the message, it then has to use the private key to decipher the message, which means private key is used to decrypt the message. As compared to symmetric encryption, the same key is used to encrypt and decrypt, but in the scenario of asymmetric, 2 different keys are used. So we have an example here. Imagine that this person in the middle here, he's the one that needs to receive message from the others. And what he will do is that he will keep the private key and allow the other people, the senders, to have the public key. And when these people wants to send a message to the receiver, so to, let's say, they want to send to a person called Bob, they will need to use this public key here, the red color key, to encrypt the message. Okay? And let's say you need to send a message here. This message has to be encrypted using a public key. And the only key that can be used to decrypt this message back to plain text is the key that Bob has, which is called the private key. So we only have one key here that can be used to decrypt the message. And the advantage of it is that the asymmetric encryption is more secure, because the public key cannot be used to decrypt a message. If we look at this diagram here, the only person that has the right to decrypt a message is Bob and not the others. Okay? And another key that makes asymmetric encryption so safe is that private key is never shared. Therefore, the people outside, even they can encrypt message and send to the receiver, they cannot and decrypt the message because they do not have the private key. The private key is only kept by the receiver. And by using this method with these 2 theories, public key cannot be used to decrypt and private key is never shared. This makes asymmetric encryption much more safer as compared to symmetric encryption. Okay, so that's the end of the encryption chapter. Alright, so in this chapter we learn about how data is transmitted. We also learn how to ensure the accuracy of data transmission using the different error detection methods. And last but not least, we learn about data encryption, which ensures that even if data is encrypted, is intercepted by others, it will make no sense to the hacker. So hopefully this video will help you revise better in chapter 2, IGCSE Computer Science. So thank you everyone.